part 2 of section 3.3. This video we can discuss what relative extrema is and how you can use the first derivative to find relative extrema. Relative extrema is just going to be finding the maximums and the minimums of a function. So we're going to start off with the first example being a graph of a function and state the relative extrema. So relative extrema just deals with the maximums and the minimums of functions. So these two right over here are the minimums, and then up here are the maximums. So as far as this problem goes, you would say that there's a relative minimum. And you want to state the ordered pair. So the minimum occurs over here at -3 and -1. So it's an ordered pair. The actual points -3 and -1. And also a minimum at the low point at 1 and -1. And a maximum is going to be basically like the little hilltops. So there's a maximum at -1 and 2. And also there's a maximum at 3, and this goes across to 3, so 3 and 3. So again, the maximum is just like the hilltops, and the minimum is just like the low points of the graph on a function. Now, how this ties into the first derivative is as follows. I'll give you a moment to copy this down, then I'll go through and explain what this means. So what you want to do is, first of all, find the critical points. So that's going to be where a relative max or relative min occurs, is at a critical point. The critical point is basically wherever you have a horizontal tangent, or where there's a derivative does not exist due to a kink. That's going to be where the extrema occurs. And you're going to have a minimum if the derivative is switching from negative to positive. And if you think about it, if you have a negative derivative, it's a function that's going to be decreasing. And then if it switches to positive, it's going to be a function that's increasing. So negative to positive would create a minimum. And a maximum occurs whenever you have a positive to negative sign change. So positive first derivative means you're increasing. Then if you switch to negative, it means you're going to be decreasing. So that's going to create a maximum. Now there will be some instances where the derivative, even though you have a critical point, doesn't change any signs. In that case, it's not going to be a maximum or minimum. You have no relative extrema. There's just a sign. There's no sign change, so no relative extrema. Alright, let's look at an actual example with a given function. And we're given that we want to find the relative extrema to g of x. So the very first thing I have to do based on the definition is find the critical points. And if you remember what a critical point was, it's that either where the derivative is equal to 0, or it's not differentiable, derivative doesn't exist. So I first have to find g prime. And again, it's easy because these were just power rules, so it's going to be a 3x squared minus 12x. This constant, the derivative of that would be 0. So I want to set this derivative equal to 0. So 0 is equal to, I can factor out a common term, which is going to be a 3x, x minus 4. So my critical points are going to be, well, if I set 3x equal to 0, that means x is going to equal 0. And then x minus 4 to 0 means x is equal to a positive 4. So these are going to be my critical points. Next, I have to find where the derivative is changing signs at these critical points. So like before, I have to do the sign analysis. Sign analysis of the derivative. So I put these critical points on the number line like before. It's going to go from 0 to 4. And I want to plug in something that's before 0 into the derivative. So g prime of -1. Something that's in between 0 and 4. So g prime of, let's say, 2. And something after 4, let's go g prime of 8. I could have picked 5, but just to show you that you don't have to pick the number that's right after this critical point, I picked the 8. Alright, let's plug in -1 into the factored derivative. It's going to be a negative. This is also going to be negative. Two negative numbers multiplied give me a positive. When I plug in a 2, this is positive now. When I plug in 2 here, this is negative. Positive times a negative is a negative number. When I plug in 8, this is a positive. When I plug in 8 here, this becomes positive. So 2 positives. Alright. So now I look back at my definition and say, okay, well, for a minimum, I'm looking for a negative to positive sign change. That occurs at 4. And for a maximum, I'm looking for a positive to negative sign change, and that occurred at x equal to 0. So I can conclude that this is going to give me a relative maximum, and this number, this critical point, gives me relative minimum. Now this only tells you the x values at which they occur. We need to find what the function value actually is when I plug it in 0 and 4 into g. So to find the exact location, you have to take these critical points and plug them back into g of x. Alright? So to find the actual points, you have to plug in g of 0. So if I plug in 0 back into a g, I get 15. So there's going to be a maximum at the ordered pair 0, 15. And then if I plug in 4 into the function g of x, I'm going to end up with negative 17. So if I plug in 4 into this, I'm going to get negative 17. And that's going to be my ordered pair, my point of 4, negative 17. And what I could do is look at this graphically and say, this is g of x, and this over here in blue is the derivative. There's a maximum at 0 and 15, and you can see that the derivative is switching from positive to the negative. And then when I get to 4, there's a negative to positive sign change, which indicates that there's a minimum. And at 4, the graph value is negative 17, and that corresponds to what we found by hand graphically. So you should copy this graph into your notes. You don't have to make it as big as this one, but just so this matches up with the example that we just got done doing. Now there is another example I want you to try on your own. So example 2b. See if you guys can find the relative extrema to this function, to h of x. But this time I'll give you a moment to pause it, try it yourself, and then in about 2 seconds I'll flip this over and show the answer. Alright, so here's the answer to 2b. Here's the derivative in case you don't get this right answer. Maybe you have the wrong derivative, so maybe this is what the derivative should have been. And the critical points I got were 0, 4, and negative 3. And there was only 2 sign changes. The sign change occurred at 4 and negative 3. And the way I got these values were I plugged 4 and negative 3 into the function, into h, through the use of a calculator. I wouldn't be able to plug in 4 into this by hand, and I wouldn't be able to plug in negative 3 into this by hand. I would have to use a graphing calculator. So that's what I did, is I found these values, these y coordinates, by plugging these numbers into a calculator. So I'll check this tomorrow, just make sure that you have this solved, that you have the sign analysis, and I can verify or I can explain stuff if you got stuck along the way. And that's it for this video.